Classical conditioning refers to a learning procedure in which a biologically potent stimulus is paired with a previously neutral stimulus. It also refers to the learning process that results from this pairing, through which the neutral stimulus comes to elicit a response that is usually similar to the one elicited by the potent stimulus. These basic facts, which require many qualifications, were first studied in detail by Ivan Pavlov through experiments with dogs. Together with operant conditioning, classical conditioning became the foundation of behaviorism, a school of psychology which was dominant in the mid-20th century and is still an important influence on the practice of psychological therapy and the study of animal behavior. Classical conditioning is now the best understood of the basic learning processes, and its neural substrates are beginning to be understood. Definition: classical conditioning occurs when a conditioned stimulus is paired with an unconditioned stimulus. Usually, the conditioned stimulus is a neutral stimulus. The unconditioned stimulus is biologically potent and the unconditioned response to the unconditioned stimulus is an unlearned reflex response. After pairing is repeated, the organism exhibits a conditioned response to the conditioned stimulus when the conditioned stimulus is presented alone. The conditioned response is usually similar to the unconditioned response, but unlike the unconditioned response, it must be acquired through experience and is relatively impermanent. In classical conditioning, the conditioned stimulus is not simply connected to the unconditioned response. The conditioned response usually differs in some way from the unconditioned response, sometimes significantly. For this and other reasons, learning theorists commonly suggest that the conditioned stimulus comes to signal or predict the unconditioned stimulus, and go on to analyze the consequences of this signal. Robert A. Rescorla provided a clear summary of this change in thinking and its implications in his 1988 article, Pavlovian Conditioning. It's not what you think it is. Despite its widespread acceptance, Rescorla's thesis may not be defensible. Classical conditioning differs from operant or instrumental conditioning. In classical conditioning, behavioral responses are elicited by antecedent stimuli, whereas in operant conditioning, behaviors are strengthened or weakened by the consequences. Procedures. Pavlov's research. The best known and most thorough early work on classical conditioning was done by Ivan Pavlov, although Edwin Twittmeyer published some related findings a year earlier. During his research on the physiology of digestion in dogs, Pavlov developed a procedure that enabled him to study the digestive processes of animals over long periods of time. He redirected the animal's digestive fluids outside the body, where they could be measured. Pavlov noticed that his dogs began to salivate in the presence of the technician who normally fed them, rather than simply salivating in the presence of food. Pavlov called the dog's anticipatory salivation psychic secretion. Putting these informal observations to an experimental test, Pavlov presented a stimulus and then gave the dog food. After a few repetitions, the dogs started to salivate in response to the stimulus. Pavlov concluded that if a particular stimulus in the dog's surroundings was present when the dog was given food, then that stimulus could become associated with food and cause salivation on its own. He called the stimulus the conditioned stimulus because its effects depend on its association with food. He called the food the unconditioned stimulus because its effects did not depend on previous experience. Likewise, the response to the CS was the conditioned response and that to the US was the unconditioned response. Pavlov reported many basic facts about conditioning. For example, he found that learning occurred most rapidly when the interval between the CS and the appearance of the US was relatively short. As noted earlier, it is often thought that the conditioned response is a replica of the unconditioned response, but Pavlov Pavlov noted that saliva produced by the CS differs in composition from that produced by the US. In fact, the CR may be any new response to the previously neutral CS that can be clearly linked to experience with the conditional relationship of CS and US. It was also thought that repeated pairings are necessary for conditioning to emerge, but many CRs can be learned with a single trial, especially in fear conditioning and taste aversion learning. Forward conditioning learning is fastest in forward conditioning. During forward conditioning, the onset of the CS precedes the onset of the US in order to signal that the US will follow. Two common forms of forward conditioning are delay and trace conditioning. Delay conditioning. In delay conditioning, the CS is presented and is overlapped by the presentation of the US. Trace conditioning. During trace conditioning, the CS and US do not overlap. Instead, the CS begins and ends before the US is presented. The stimulus-free period is called the trace interval. It may also be called the conditioning interval. For example, if you sound a buzzer for 5 seconds and then, a second later, puff air into a person's arm, the person will blink. After several pairings of the buzzer and puff, the person will blink at the sound of the buzzer alone. The difference between trace conditioning and delay conditioning is that in the delayed procedure the CS and US overlap. Simultaneous conditioning. During simultaneous conditioning, the CS and US are presented and terminated at the same time. For example, if you ring a bell and blow a puff of air into a person's eye at the same moment, you have accomplished to coincide the CS and US. Second-order and higher-order conditioning. This form of conditioning follows a two-step procedure. First, a neutral stimulus comes to signal a US through a forward conditioning. Then a second neutral stimulus is paired with the first and comes to yield its own conditioned response. For example, a bell might be paired with food until the bell elicits salivation. If a light is then paired with the bell, then the light may come to elicit salivation as well. The bell is the CS1 and the food is the US. The light becomes the CS2 once it is paired with the CS1. Backward conditioning. Backward conditioning occurs when a CS immediately follows the US. Unlike the usual conditioning procedure, in which the CS precedes the US, the conditioned response given to the CS tends to be inhibitory. This presumably happens because the CS serves as a signal that the US has ended, rather than as a signal that the US is about to appear. For example, a puff of air directed at a person's eye could be followed by the sound of a buzzer. Temporal conditioning. In temporal conditioning, a US is presented at regular intervals, for instance every 10 minutes. Conditioning is said to have occurred when the CR tends to occur shortly before each US. This suggests that animals have a biological clock that can serve as a CS. This method has also been used to study timing ability in animals. Zero contingency procedure. In this procedure, the CS is paired with the US, but the US also occurs at other times. If this occurs, it is predicted that the US is likely to happen in the absence of the CS. In other words, the CS does not predict the US. In this case, conditioning fails and the CS does not come to elicit a CR. This finding, that prediction rather than CS-US pairing is the key to conditioning, greatly influenced subsequent conditioning research and theory. Extinction. In the extinction procedure, the CS is presented repeatedly in the absence of a US. This is done after a CS has been conditioned by one of the methods above. When this is done, the CR frequency eventually returns to pre-training levels. However, spontaneous recovery show that extinction does not completely eliminate the effects of the prior conditioning. Spontaneous recovery is when there is a sudden appearance of the after extinction occurs. These phenomena can be explained by postulating accumulation of inhibition when a weak stimulus is presented. Phenomena observed. Acquisition. During acquisition, the CS in US are paired as described above. The extent of conditioning may be tracked by test trials. In these test trials, the CS is presented alone and the CR is measured. A single CS-US pairing may suffice to yield a CR on a test, but usually a number of pairings are necessary. This repeated number of trials increase the strength and/or frequency of the CR gradually. The speed of conditioning depends on a number of factors, such as the nature and strength of both the CS and the US, previous experience and the animal's motivational state. Acquisition may occur with a single pairing of the CS and US, but usually, there is a gradual increase in the conditioned response to the CS. This slows down the process as it nears completion, extinction. In order to make a learned behavior disappear, the experimenter must present a CS alone, without the presence of the US. Once this process is repeated continuously, eventually, the CS will stop eliciting a CR. This means that the CR has been extinguished. External inhibition. External inhibition may be observed if a strong or unfamiliar stimulus is presented just before or at the same time as the CS. This causes a reduction in the conditioned response to the CS. Recovery from extinction. Several procedures lead to the recovery of an extinguished CR. The following examples assume that the CS has first been conditioned and that this has been followed by extinction of the CR as described above. These procedures illustrate that the extinction procedure does not completely eliminate the effect of conditioning reacquisition. If the CS is again paired with the US, a CR is again acquired, but this second acquisition usually happens much faster than the first one. Spontaneous recovery. Spontaneous recovery is defined as the reappearance of the conditioned response after a rest period. That is, if the CS is tested at a later time after conditioning, it will again elicit a CR. This renewed CR is usually much weaker than the CR observed prior to extinction. Disinhibition. If the CS is tested just after extinction and an intense but associatively neutral stimulus has occurred, there may be a temporary recovery of the conditioned response to the CS reinstatement. If the US used in conditioning is presented to a subject in the same place where conditioning and extinction occurred, but without the CS being present, the CS often elicits a response when it is tested later. Renewal. Renewal is a re-emergence of a conditioned response following extinction when an animal is returned to the environment in which the conditioned response was acquired. Stimulus generalization. Stimulus generalization is said to occur if, after a particular CS has come to elicit of CR, another similar stimulus will elicit the same CR. Usually the more similar of the CS and the test stimulus, the stronger is the CR to the test stimulus. The more the test stimulus differs from the CS, the weaker the CR will be, and the more it will differ from that previously observed. Stimulus discrimination. One observes stimulus discrimination when one stimulus elicits one CR and another stimulus elicits either another CR and no CR at all. This can be brought about by, for example, pairing CS1 with an effective US and presenting CS2 with no US. Latent inhibition. Latent inhibition refers to the observation that it takes longer for a familiar stimulus to become a CS than it does for a novel stimulus to become a CS, when the stimulus is subsequently paired with an effective US. Conditioned suppression. This is one of the most common ways to measure the strength of learning in classical conditioning. A typical example of this procedure is as follows. A rat first learns to press a lever through operant conditioning. Then, in a series of trials, the rat is exposed to a CS, a light or a noise, followed by the US, a mild electric shock. An association between the CS and US develops, and the rat slows or stops its lever pressing when the CS comes on. The rate of pressing during the CS measures the strength of classical conditioning, that is, the slower the rat presses, the stronger the association of the CS and the US. Conditioned inhibition. 3 phases of conditioning are typically used. A CS is paired with a US until asymptotic CR levels are reached. CS plus US trials are continued, but these are interspersed with trials on which the CS plus is paired with a second CS, but not with the US. Typically, organisms show CRs on CS plus US trials, but stop responding on CS plus CS minus trials. Phase 3 summation test for conditioned inhibition. The CS from Phase 2 is presented together with a new CS plus that was conditioned as in Phase 1. Conditioned inhibition is found if the response is less to the CS plus CS pair than it is to the CS plus alone. Retardation test for conditioned inhibition. The CS from Phase 2 is paired with the US. If conditioned inhibition has occurred, the rate of acquisition to the previous CS minus should be less than the rate of acquisition that would be found without the Phase 2 treatment. Blocking this form of classical conditioning involves 2 phases. Phase 1, a CS is paired with a US. Phase 2, a compound CS is paired with a US test. A separate test for each CS is performed. The blocking effect is observed in a lack of conditional response to CS2, suggesting that the first phase of training blocked the acquisition of the second CS.